All right, this is Mr. Wyrick, and I'm going to be going through these notes with you for Friday. I will be out. There will be a tennis tournament. So right off the bat, we see 3.2 rigid motion without coordinates. If I didn't get to say it on Thursday, welcome to Unit 3. So there's a couple of different rigid motions. The rigid motions mean that we are maintaining the size of the shape. Nothing is changing about it except its location in some form. So when we have rotation, we turn that figure. So here we're taking this triangle and we're just rotating it a little bit clockwise or counterclockwise. If you're not sure about that, you can look at like a watch face. If you go the direction of the numbers, top to the right, that's clockwise. If you go the direction against the numbers, 12, 11, 10, 9, whatever, that's counterclockwise. So it takes a center of rotation. You have to have a point that you're rotating around, usually the origin, sometimes a different one. Like today, we're doing ones that don't have the coordinate plane on there, so it'll just be typically one of the vertices of the shape. And then the direction of rotation, it has to go clockwise, it has to go counterclockwise, and it has an angle. How many degrees is it rotating? Is it rotating 45 degrees? Is it rotating 90 degrees? Whatever it is. Okay, so that's rotation. The next slide is going to be reflection. It's reflected over an axis of symmetry, up and down, left and right. You can do this with your phone screen. If you set the screen of your phone kind of against like this, you should be able to see the reflection of that, so you can tell. And you can look at it and see, oh, this flipped over. We can see that kind of symmetry there. Translation is the next one. We are just moving stuff. So we have this line, this ray, and we're translating it down here, or we have this triangle and we are translating it down here. It just slides things over. This is much easier to do in the coordinate plane, because then you have, we're going this many units right or left, this many units up or down. But as it so happens today, we're just looking at kind of sliding it over. Okay. So the rigid transformations, it's important to write those down, know what they are. But again, the shape is still the exact same. The sides are still the same length. All the angles are still the same. We did not make a new shape. We just moved to where it is. So it's gonna stay congruent to what it was. We haven't made any changes like that. Your assignment for today is in Delta Math. It's called Mapping Without the Coordinate Plane. I have it sitting here in Delta Math ready to post for you. When we take a look at this, when we go mapping without the coordinate plane, it asks, what do you need to do to take triangle RST and make it into triangle TKL or KLT or whatever it is. So in this one, I can see I just need to take this and turn it to get it up there. So I'm going to call this a rotation. I'm going to tell it to use point T since that is already touching. And it's asking about sides that have the same slope. It really doesn't matter which ones that you pick. I'm going to pick RS here. And I'm going to make RS have the same slope as KL. Luckily, if you get stuck on this one, it does allow you to try it. And it shows you in motion what happens when you do that. If it ends up in the right place, it'll say, oh, you're great. Go ahead and submit that answer. You get the credit for it. If you try it and you end up not doing quite the right thing, like let's say I want a translation and I say something like, oh, I want point J to be on point Y. When I try it, it's going to move the triangle over there too far, and it's going to say, I'm not quite there yet. So I can reset the whole thing, or I can just say, oh, I missed it. It should have been point Z. Try it, and it moves it over there, and it gets it in the right spot and says that I'm right. Okay, you really can't miss these. You just have to work your way through them. Hopefully that'll get you done. You'll be able to finish that up, and you'll have a great Friday and a good weekend. We'll see you Monday.